Assalamualaikum warahmatullahi wabarakatuh and good morning to all of you. My name is NORHANI binti RUSLI and today I would like to present my poster and the title is Assessing Rate of Deforestation and Change of Carbon Sink on Mangrove in Pahang, Malaysia. For my introduction, mangrove forests play an important role as a substantial coastal carbon sink. However, despite being a crucial component in the global carbon cycle and having potentially profound influence on climate change, the aerial extent of mangrove forests has declined significantly as a result of a coastal development, aquaculture expansion, and overharvesting. For objective, to assess the loss of carbon stock on mangrove forests caused by the change of land use of mangrove over the entire state of Pahang. The second objective is to provide information on deforestation of mangrove ecosystem over the entire state of Pahang. For method, satellite data analysis. First, Landsat 5TM, Landsat 7 ETM+, and Landsat 8 OLI satellite. Image were georeferenced by two Malaysia res-certified Q orthomorphic MRSO projections, so the image registered with the same coordinate system and then processed to classify mangrove area and separate from other land covers. The second method is the result exported in a vector format to be refined and edited in GIS to execute post-classification process. The third method is change with identify from post-classification change detection technique. The fourth method is the chain will categorize into four types. First is land use or land development activities. Second is agricultural conversion. The third is aquaculture activities. And the fourth is erosion and others. Field sampling inventory. Field inventory data from 3 forest reserves was collected. The second is the diameter of the mangrove with diameter more than 10 cm was measured in square subplot measuring 20 times 20 cm. The third is biomass of each tree was calculated using allometric equation. The last is the calculated biomass was converted into C by using constant factor of 0.47.
For results, here we have Figure 1, Table 1 and Table 2. Figure 1 shows the changes that occurred between years 1995 and 2014. The boundaries of mangroves have been shrinking from 1995. However, these changes only affected the Landsat area, for example, outside forest reserve. For Table 1, it summarized the sampling plus information that was collected from field inventory. The average value was used as a single factor that was multiplied by the mangroves acreage. Table 2 shows the extent of mangroves that were obtained from image classifications. Table 2 shows the extent of mangroves that were obtained from image classifications. In addition to the 10-year interval satellite data, secondary information was used, which has made the observation period reduced to 5-year intervals. Deforestation of mangroves in Pahang was about 2,900 hectares since 1990, with the rate of deforestation was about 123 hectares per year. Mangroves in Pahang are mostly found in Kuantan district. However, 31% of urban developments and 26% of agriculture sector caused the decline in extent of mangrove. In conclusion, this study successfully determined the rate of deforestation and changes of carbon stock in ecosystem since 1990 to 2014 in mangroves in Pahang. And also the combination of field inventory data and remote sensing data produce a reliable estimate carbon stock in mangrove and can be used to detect changes over time.
Our recommendation. This study suggests that the state government should protect our priceless mangrove and any development should be implemented with caution. For our acknowledgement, the author gratefully acknowledged to the financial support by FRIM. The author would like to thank the government of Pahang for providing permission to conduct this research. Thank you.
Last but not least, this is the references that we have been used to prepare this poster. Thank you for watching and listening.